Wanna rock and roll all night and party every day. I wanna rock and roll all night. Okay, got it, man, got it. All right, ladies and gentlemen, welcome. Little honors algebra 2. Gonna do a little review. Gonna hit some problems from that are similar to a worksheet you're gonna be working on here. I'm pretty fired up today. I'm really excited. It's Wednesday. It's hump day. I love it. All right, we're going to do a handful of problems that are like the problems on the worksheet. They're all about properties of exponents. They're about rational exponents. A lot of fun. Okay, first one. 5x cubed squared. We got 5x cubed to the negative second. We got 5x cubed to the 1/2. We got 5x cubed to the negative 1/2. They're all different. They're similar but different. First one, we're going to do power of a product and power of a power. We're going to do 5 squared, which is 25. That was easy. We're going to do x cubed squared, and that's x to the 6th. Beautiful. All right, second one. Negative exponent. That's going to be 1 over. It's going to be 1 over the exact same thing we got here. 25, x to the 6th. The negative exponent makes it 1 over. Easy peasy. Letter C, we got a fractional exponent. We're going to do the same basic thing, but it's a little harder. This time, instead of 5 squared, we have 5 to the 1/2. Instead of x cubed squared, we have x cubed to the 1/2. 3 times 1/2 is 3/2. You could leave it like this if you wanted, or you could write that as the square root of 5 times x to the 3/2. Either one of those is right. Okay, letter D. Got a negative exponent and a fraction exponent. So it's going to be 1 over this square root of 5x to the 3/2. You could also write this, if you wanted to, as x to the negative 3/2 over the square root of 5. Can't leave square root of 5 in the bottom. Root 5 over root 5. And we end up with the answer. I'm going to write it over here. We end up with an answer of the square root of 5 times x to the negative 3/2 over 5. That would be if we rationalized our denominator. So this here, if you're taking notes at home, this went with C, and this went with D. So the first problem on the worksheet is 4 problems just like that with different numbers in them, though. All right, number 2, we got this polynomial divided by the monomial, and what you do for one like this is you look at each term divided by the denominator. You kind of look at 3 different problems in one. So we're going to do 10x squared divided by 4x squared, x to the 4th. 10 fourths is 5/2. X squared divided by x to the 4th, that's x to the negative 2. And then we have the second term, 5 fourths, x to the negative 3. And then we have plus 3 fourths, x to the negative 4. Okay? Just subtracting the exponents. Okay, the next one, same idea, a little harder because we have fractional exponents. We have 10 divided by 10, well, that's just 1. X to the 5/2 divided by x, that's x to the 5/2 minus 1. That's x to the 3/2. And then we have 5/10, that's 1/2. X to the 3/2 over x, that's x to the 3/2 minus 1, that's x to the 1/2. And then we have 3/10 x to the negative 1, because we don't have an x there. Okay, so those are 2 examples that are just like the problems in number 2. All right, let's look at number 3. All right, we got the dreaded ceiling tile making another appearance. The dreaded ceiling tile problem. Let's switch to blue. I like blue. Go blue and red. The ceiling tile. Okay, we're not going to just do the first term squared minus second term squared. We're going to do the first term squared, 9x to the 4th, minus 2 times 3 times 2, because we do twice the product. 2 times 3 is 6 times 2 is 12x squared, and then we square that term. Boom. All right, now this one. Okay, all of a sudden, We got a fractional exponent. Oh my goodness gracious. We're not going to just throw all our rules out the window. We're going to do it exactly the same way. We're going to square this term. Oh my. That's 9x to the 1/2 squared. That's just x. Minus, we're going to do 2 times this product. That's going to be 12 again. X to the 1/2. And then plus 4. Now you can write it like this, or you could write it like this. 9x minus 12 times the square root of x, because that's the square root of x, plus 4. Either one of those are correct. Now this was just, this example here was about being careful of the ceiling tile. He comes up again down here as well. All right, let's see, number 4a. X to the 4th to the -1. All right, 2 ways of looking at that. You can think of it as multiply those, you get x to the -4. Totally correct, 100% correct. Or you could say that negative makes it a fraction, so it's 1 over x to the 4th. These two are equal to each other, so either way is correct. Sometimes the directions of the problem tell you which way to do it. In any case, those are the same. This guy over here, exactly the same idea. We're going to do, let's see, 3 to the -1, that's 1/3. X to the 4th to the -1, that's x to the -4th. Y to the -5th. Or you could think of this as, just flip this, 1 over this. So this is equal to 1 over this. 3x to the 4th, y to the 5th. These two answers are the exact same as each other, and either one would be correct. All right, here we go. That ceiling tile situation here. Because we got a polynomial, in this case a binomial, raised to the -1st power, raised to a power. We don't just take the -1st power of each term, because that is a polynomial. It's a binomial in this case. So instead, we're going to do 1 over the whole thing. That's the answer. We don't go any farther than that. We stop. That's the total and complete answer. All right, this guy here. Woo! Same idea. We're not going to do -1 to each piece because it's a plus right there. So instead, we do 1 over x to the 2/3 plus y to the 1/2. That's the answer. That's not the same. This is not the same as 1 over x to the 2/3 plus 1 over y to the 1/2. These are different. They're not equal. Do not say this. This is wrong. And we're going to see an example of why it's wrong in just 1 second. I think right down here, these two kind of explain why that last one was wrong. All right. Is x squared plus y cubed quantity squared the same as x to the 4th plus y to the 6th? Meaning, can I take that 2 on each of these? Or if I do that, will I get hit in the head, bonk, with a ceiling tile? Yeah, I think I will. So I can't do this. This is no. Because if I square this, I get the first term squared plus multiply these together. I get a 2x squared y cubed, plus now I have to square y cubed and get y to the 6th. So if I multiply this by itself, I get this middle term. Remember, I got the middle term, which doesn't exist right here. All right, last problem we're going to look at. Is 1 over x plus 1 over y the same as 1 over x plus y? Or is it 2 over x plus y? Remember, when you add fractions, do you just add the bottoms and add the tops? Do you add the bottoms and keep the tops the same? Or do you have to find a common denominator? Yeah, you got to find a common denominator whenever you add fractions. So, if I'm doing this problem, I go, okay, common denominator is going to be xy. Common denominator is just x times y. And we multiplied this 1 by y. We multiplied x by y to get xy. So we have to multiply 1 by y to get my new numerator. Over here, we multiplied this y by this x to get that xy. So we have to multiply its numerator, 1, by the same thing, which was x. So this Not this, but this. Now, those two ideas help you with number 6. Not exactly. I don't want to give it away. But the problem with number 6 really is making you think. The question number 6 on the worksheet. All right. I hope you enjoyed today's video. It was brief, but you really need you to watch it, obviously, before you attempt to do the assignment. See you later. Have a great weekend.